Dear all, so far we have seen about the type of semiconductors like elemental semiconductors. Uh, this is the elemental semiconductors based on the composition, and we have also seen about the intrinsic semiconductor, extrinsic semiconductor. This is based on the impurities. Okay. Now we have another type of semiconductors, that is direct semiconductor and indirect semiconductor. See, the direct semiconductor, you can see this one is the valence band and this one is the conduction band. So valence band and conduction band. In direct semiconductors, you see that both valence band and conduction band lies in the same plane. Okay, both valence band and conduction band lies in this same plane. Okay, so you have a parabolic valence band, okay, because the energy of electrons are different. So we have parabolic valence band and also the parabolic conduction band, because this states the difference in the energy level. Okay, but generally we will have a flat band diagram for this valence band and conduction band, but here we have here it is like parabolic. This shows the difference in the energy level. And for the direct band gap semiconductors, you have both valence band and conduction band lies in the same plane. Okay, so that what will happen, the electrons will go from the conduction band. It will go to the electrons will go from the valence band, it will go to the conduction band, and after that it will come to the conduction band emitting a light, emitting a photon. Okay, so it is easy for the electron to come from conduction band to valence band for the direct semiconductor. So for the direct semiconductor, valence band, conduction band lies in the same plane. So the electron from conduction band will come to the valence band emitting a photon. But you see here in indirect band gap, both the valence band and conduction band not lies in the same plane. So here the electrons from the conduction band has to lose some energy and it will come to the valence band. Okay, so there is some loss of energy here. The dissipation of energy results in either phonon, it's a vibration, okay, or it will heat will get emitted. Either phonon emission will be there or heat will get emitted. So this is the difference between direct bandgap semiconductors and indirect bandgap semiconductors. In direct bandgap, valence band, conduction band lies in the same plane. In the indirect bandgap, it won't lies in the same plane. Direct bandgap materials, the electron from the conduction band comes to the valence band and photon is get emitted or light will get emitted, but it's not, that will not take place in the indirect bandgap materials. Now you see elements. See, these are the examples for direct and indirect semiconductor materials. See, element germanium and silicon or indirect bandgap materials. So germanium and silicons are used in integrated circuits because they can't emit light, because since they are indirect band semiconductor, it is not possible for them to emit light. So they are used in integrated chips. But you see, gallium arsenide, indium arsenide, gallium nitrate, these are direct bandgap materials. These materials are used in LED, laser, etc. because this will emit light. Why this will emit light? Because valence band and conduction band lies in the same plane. So these examples for indirect bandgap material or germanium and silicon. Examples for direct bandgap material, gallium arsenide and indium arsenide, etc. Okay, keep it in mind, direct bandgap material will emit light while indirect bandgap material will not emit light, and it is used in integrated circuits where direct bandgap materials are used in LED and laser because it emits lights. Just see here, this is the direct bandgap materials. Okay, LED and laser, these are emitting light. So in LEDs and laser, direct bandgap materials are used. Now you see integrated circuits. Okay, we have amplifiers, oscillators, etc. in the integrated circuits. In this integrated circuits, not silicon is used in this integrated circuit. Silicon is a indirect bandgap material. Okay, so this is the differentiation between direct bandgap material and indirect bandgap materials and applications. Direct bandgap materials are used in optoelectronic devices, while indirect bandgap materials are used in integrated circuits. Okay, thank you.